Hey guys, Mr. Stair here with a quick note for geometry. Now this video that I'm making is in addition to the one that I have assigned to you through Pearson Realize. The videos on Pearson Realize show you how to do the problem one way, and I'm just going to show you a different way to do it. The way on Pearson Realize that they show you how to do this, first off, what we're doing here is we're just finding the area of a regular polygon. But this time what we're going to do is, with Friday's review assignment, I know it's been 3 days, but Friday's review assignment really focused on trigonometry, just a review of those three trigonometric functions: sine, cosine, tangent. And so that's what we're going to look at here. All right, so regular polygons, the area of regular polygons with trig throughout this lesson here. All right, so the way that Pearson Realize is asking you to do it is they're asking you to find this formula, or excuse me, use this formula: 1/2 of the apothem times the perimeter, right? And so they're going to go through some steps to find the perimeter, to find the apothem, and then go ahead and plugging that in from there. But I'm going to show you a different way, right? Kind of keeping in line with the videos that I've been showing with this method. We are going to be taking a look at the same two examples that they're doing, coming to the same answer, concluding with that. But what we're going to do here is we're going to use areas of triangles, right triangles, excuse me, to help us figure that out. All right. So example 1 there on the Pearson Realize video, it's talking about a regular nonagon with a single side length of 10 centimeters, right? So this definitely is not going to be a perfect nonagon, a shape with 9 sides, but we'll give it our best here. Already off to a poor start. Let's see what we got here. Let's see if I can make it more steep. And again, it doesn't have to be perfect here. We know it's got to be 9 sides, so we'll just say that's our nonagon there. And one of the sides has a side length of 10 centimeters. Now, we're going to do this the same way to start with, right? If I just take and look at one triangle, that's all I'm trying to focus on here, right? With this being the center of the shape, okay, we'll just call it C for being the center. We're going to try to find out what is the degree of this inside angle, right? And the way that we do that with any shape is just taking 360 divided by the number of sides. So count them up: 1, 2, 3, 4, 5, 6, 7, 8, 9. 360 divided by 9, or just 40 degrees, right? So each one of those is going to be 40 on the inside. But that's not really going to help us out. So what we're going to do here is, with each inside angle being 40, that means if I made some right triangles, that this right here would be 20, right? Along with this one being 20. So that's where the 40 comes from. Now, if I have divided it in half, that triangle, that means that I know some information right here about this 10, right? This 10 I know is a 5 here, and I know it's a 5 there on the right-hand side as well, right? So this is 5, and then the same with this also being 5, okay? Now, here's what I'm going to do. Okay, in order to find the area of this triangle, it looks like I'm going to need a height. I know the entire length is 10. I know that I have a 20 degrees on top, and but I am missing that height right there. So I'm going to adjust my camera, bring it down here, and I'm going to redraw that triangle just a little bit bigger here so we can see what's happening, right? So one of these triangles, it looks like this, and again, it's definitely not to scale here, but the real question is, what trig ratio do I need to find this missing side length, right? I'm not worried about the hypotenuse, so what is the trig ratio that talks about finding opposites and adjacents in relation to this angle. Remember, 5 is the opposite. It has nothing. It has no common vertices with the 20. And the x right there is definitely not the hypotenuse, so that just makes it the adjacent, right? So if we recall our phrases, so, ka, toa, right? The only one that has to do with opposite and adjacent is the tangent. So I'm looking for the tangent of 20 degrees equals, and again, be careful, we need to set this up in the right order, with the opposite being on top and the adjacent being on bottom. Again, hopefully this is second nature, but we know that x is going to be the same thing as 5 over the tangent of 20, right? Now, this is all going to give us just the height of one of these individual triangles here, right? So let me pull up my handy dandy calculator here, and we'll take a look at 5 divided by the tangent of 20. And I'm just going to round this to about 3 decimal places here. Make sure that you guys can still see it. It's 13.737, right? So this 13.737 is just this right here. So again, if I'm thinking about this triangle, right? This triangle had a central angle of 40, side length of 10, and its height is just 13.737. So that's how I could find this here. Now, if I think about finding the area of this triangle, again, just 1/2 base times the height. Let's see if I can get this written down here. 1/2. The area is 1/2 base times height. So if I just go ahead and plug my numbers in, 1/2 of 10 times 13.737. Go ahead and, using the handy dandy calculator, go ahead and plug that in. And I'm just coming up with an area of 68.6869, right? For lack of a better word. Now, when I do this here, I need to be thinking that, oh, this is not going to be my final answer. This is just the area of one of the triangles. And we have to think about how many triangles do I actually have in this shape? Well, if I'm thinking about it, it looks like I am running out of room here. So I'll just move it right here. If I take the area of one triangle and multiply it times the amount of triangles that I have, right? We'll just say, if I round this to 2 decimal places, times 9, because it's a 9-sided shape. Again, using that calculator, it looks like it's asking us just to round it to the nearest meter. And so we could say, you know what, it's going to be 618 centimeters squared, right? So 618 is my final answer. Again, what I'm really thinking about right here is just taking a look at the shape, 360 divided by the number of sides, divide that angle measure in half, using some trig to go through that. If it's giving me the side length, like it did here, of 10, then most common times I'm going to use the trig ratio tangent to come up with that. Find the area of one of these triangles and just multiply it times the number of sides, right? So that's one way to take a look at this. Now, the second example that they're going to